Okay, so another video lesson on these chapter review problems for chapter 4, congruent triangles. We're going to try a proof now. First step in a proof usually is to do the pre-planning, marking the diagram based on the givens, inferencing anything from those, and inferencing anything you can from the diagram itself. Okay, so the fact that yx is congruent to wx is given. They did mark that. Zx bisecting this angle, yxw. You should follow that path and figure out which angle they're talking about. Okay, they're talking about that one right there. Now that got bisected, so what we end up getting is, let's see, right there. That angle and that angle are congruent right there. Okay, let's see. There's not a whole lot else. All I can think of right now that we know for sure is xz is congruent to itself. Is that going to help us with yz and wz? I think so, because what we can prove now with this one, if you really check it out, we don't really need that at all. If you check this out, triangle xyz, we can prove it's congruent to triangle xwz. That's going to be by, looks like side angle side. Now, in a case where they actually went and did the proof part of it for us, we're going to have to follow their path, try to go through what they did and give reasons for it. Okay, on our own, we do it our own way, but let's see if we were right. So yx is congruent to wx, and what justifies that? The reasons are basically what tells us that that's true. Well, it's given. So when we get these arbitrary situations, they got to give us some information. Xz bisects that angle. That was also given. Okay, that was up here. These are our two givens, and we used them. Now we probably have to either draw a conclusion from them or use that reflexive. Let's see. Those angles, yep, those are the ones. So that is right here. What we can say is definition of angle bisector. That's one way to go. There are other ways, but that's one way. Okay. All right. XZ is congruent to itself. We can call that reflexive property. Now, the reason we say that is because it's, we're going to say that we're going to prove it by side angle side. Well, that gets us a pair of sides. So now 5, those two triangles are congruent by the side angle side triangle congruence theorem. And the 6th move right here, that is because of they are corresponding parts of congruent triangles. So I'll write that out. Okay, corresponding parts of, I'll even say sides, corresponding sides on congruent triangles are congruent. Okay, next one. Okay, so we're going to prove that Mn, interesting. I think this X was in the way, was not meant to be there. So it looks like we're going to prove Mn is congruent to Qt. Okay, let's see. It appears that they're giving us, okay, so the givens, based on the marks, must be that MQ is congruent to TN. I'm just kind of estimating that because it doesn't look like there's any givens. So it's marked, so we can assume that. We can also assume, because of the arrows, that MQ is also parallel to TN. Okay, and that's all we're going to need for this, because what we're going to get is, if you look, we have this backwards Z, right? So I always teach my students to look for the backwards Z's or N's or whatnot. And then what that's going to give you is the inside corners of those is going to be your alternate interior angles. So there's going to be congruent. So we can mark those. Then we'll have a pair of sides, right? They're already marked. And then we can add that in the reflexive property. So we got a side angle side proof. Okay. So what we're going to do is we're going to show triangle MQT. Now be careful. When we write this congruent statement, we got to get the letters coordinated here. So this top triangle, I'm going M to Q to T. I should match M with its corresponding down here. Believe it or not, it's T. Okay? Angle M in the top triangle is matched to angle T in the bottom. And then we go to Q is matched with N. And then, let's see, actually this T right here is matched to that one. Okay? So we're gonna have to switch those a little odd, but we'll have to do that. And that's gonna be by looks like side angle side. Now this is just my pre-proofing here. Now I'm going to actually go write a statements and reasons proof. You can do a T-chart or however you want to do it. Okay. I'm going to do a T-chart. That's what we're used to. So I want to start with a pair of sides. All right. To me, it looks like MQ was marked congruent to TN. I'm going to say it was given. Okay. I want a pair of angles. The angles I'm going to get are because of alternate interior angles. So really, that's going to be step 3. Okay. I'm going to get angle QMT congruent to angle NTM. And that is because of alternate interior angles theorem. Now the theorem is alternate interior angles are congruent when parallel lines are cut by a transversal. If your teacher allows you to shortcut a little bit, great. If not, you're going to have to write that out. But before I can say this theorem of parallel lines, right, it's dependent on having parallel lines, but I don't have them yet in my proof. That's why I left a space. If you're dependent on parallel lines, your proof better have that earlier in the statements section, and it does need it. Okay, so then that's going to be also given. So that's the relationship here. They're given parallel. That's going to give us congruent alternate interior angles. All right, now on our own, we could write MT. I'm not going to switch the order, even though that's probably more accurate. It's called reflexive property. And now I can write that the triangles are congruent. What did I say up here? I'll just use it the same way. Looks like MQT is what I went up there, and TNM, and that was by the side angle side triangle congruence theorem. And now we can say what we're meant to say, which I believe was Mn congruent to TQ. Mn, these two, right? Congruent to TQ, those two. So that is by, again, corresponding parts of congruent triangles are congruent. And it depends if your teacher allows that shortcut CPCTC. And there it is. Or if you forget that, you can say, you know what, it's because they're corresponding sides on congruent triangles. The key word is corresponding. As soon as I see that word, I'm probably going to be looking to give you credit there. But corresponding has to be there. All right, I'm going to run the, this will be it for this video, and then I'll run the other proofs on the next one.